derivative of this. When they are given, this is the given function. Correct. So when this is the given function, you can see clearly this given y equal to f of x given function. Then if you write derivative of this dy by dx, we will write dy by dx equal to, I can write f dash of x. Derivative of y with respect to x. Derivative with, this is the notation. Derivative of x. Here I can also the meaning d by dx of f of x means f dash of x. So derivative of f of x with respect to x. We can write like this. By here, suppose when you have taken the function here, they will write at a particular point we should define the derivative f of x at x equal to a. They are talking derivative of f of x at x equal to a. So generally they may represent the derivative, always they may write f dash of x equal to, see the derivative they are writing here, f dash of x equal to, they will write limit h turns to 0, f of x plus h minus f of x by h. This is the derivative. We can also say this is first principle of the derivative. We can also say this is first principle of the derivative. I can say this is by h. I can say first principle of the derivative. Limit h turns to 0, f of x plus h minus f of x by h is called first principle of the derivative. Always this you can use it. Suppose they are asking derivative of f of x at x equal to a. When they are talking derivative of f of x at x equal to a. So derivative of f of x at x equal to a. So derivative of f of x at x equal to a. When they are talking at x equal to a, the mean at x equal to a means I can write this f dash of at x equal to f dash of a. F dash of a. This is nothing but limit h turns to 0, replace x with a, f of a plus h minus f of a by h we can express like this. So this is a derivative of f of x at x equal to a, f dash of a, limit h turns to f of a plus h minus f of a by h. Now, when I have written like this, so for every function the derivative I can find using this concept f dash of a, the derivative of any function at x equal to a. For example, I will take an example. So f of x is equal to, I have taken one function. For example, I have taken f of x is equal to, for example, x. How to find derivative of this one? I can find derivative of f of x equal to x means, so you can think I want f dash of x. So f dash of x I can consider. When they are asking f dash of x is equal to x, use the first principle, then I can write f dash of x is equal to limit h tends to 0, use same formula, f of x plus h minus f of x by h. I can take this. Now function is f of x equal to x, but you write limit h tends to 0, f of x plus h means replace x with x plus h. You will get x plus h minus f of x is x by h. X will get cancelled. Limit h tends to h by h. You can observe here limit h tends to 0, h by h. Limit of constant is constant. We know that. That means derivative of f of x is equal to 1 when f of x equal to x. That means I can write d by dx. So the meaning here I can write d by dx of x is equal to 1. Derivative of x is equal to 1. Remember the most important one. Derivative of x is equal to 1. Always you can remember. Derivative of x is equal to 1. So can I do like this and then try for derivative of x square? For example, you try f of x equal to, I am talking about the second one. Suppose f of, I can write, see here, I can also try this. For example, I have written f of x is equal to x square. You think about this one. When I have taken this one, f of x equal to x square. Now you can observe here, if I take f of x equal to x square, correct. Now, you think about it, I have taken f of x equal to x square. Then what it happens now? F of x square, same thing, you try to find derivative of this f of x square. So you take f dash of x is equal to, I can write f dash of x is equal to limit h tends to 0, same apply formula, f of x plus h minus f of x by h, same formula, limit h tends to 0. What is f of x plus h? Replace x with x plus h, x plus h whole square minus x square by h. Alright, this one I can write like this. Now here this expression, you can observe this one. When I have written this expression, just this is a square minus b square. So limit h tends to 0. Correct. You can write limit h tends to 0. Limit h tends to 0. This will be a square minus b square. So a plus b a minus b. X plus h plus x. I can write into x plus h minus x by h. Correct? A plus b a minus b. Here xx will get cancelled. This will become limit h tends to 0. X plus x. 2x plus h into this is h by h. H's will get cancelled. Apply the limit 2x plus 0. Answer is 2x. That means what's your conclusion? I can write here. Understood here. Now you can see, you can respond. Are you able to understand? Is it clear? Are you able to see that? Yeah, please respond to the chat box. The screen is clear. Are you able to understand, right? It's clear, right? Yeah. Yes. The people who can respond, everyone, when they are getting doubt also can respond that. Now coming to this, I got this one. I can write d by, now I can write d by dx of. So derivative of. So therefore I can write d by dx of now. D by dx of, that means x square. I got x square is equal to 2x. So derivative of x you got 1. Derivative of x square 2x. I got 2x. Now I am going to generalize this. Suppose if I find derivative of, for example, you consider f of x is equal to x power n. You take this. You try to do this. Suppose f of x power n. Then how to do this? I have done x power n. Then can you try this now? Everyone try this. F of x equal to x power n. Use the first principle formula. Try to find the derivative of that using first principle. F of x equal to I given x power n. Now you do that. Then what it comes now? F of x equal to x power n. Try to find this. Do it now. You will get an idea about that. You do it now. F of x equal to x power n. Substitute and you can verify that. F of x equal to x power n. Right? So I have taken x power n. I want this generalization because n value anything. What is x power n? If I take f of x equal to x power n, how to find derivative of this? Right. But you write I am talking let take f of x power n. If you want to get it for n is any positive integer, anything I can write. So you see now f dash x equal to, I can write f dash of x equal to same thing. Limit h tends to 0. F of x plus h minus f of x by h formula. Always remember in the exam, they may ask using first principle of the derivative. Clearly they may ask, use the first principle of the derivative. This is first principle of the derivative to solve the problem. Use first principle of the derivative to solve the problem. Then I can write limit h tends to 0. Now I can write this one. X plus h whole power n. X plus h whole power n minus x power n by h I can write. Correct? We can express like this. You can observe this one, right? You can express that way. It's clear now. Now this one I can write. This is the power n power n. This, what I will do now for our convenient, I can write this one limit h tends to 0. Both are same power. We can also write limit h tends to 0. Right, this one. x plus h whole power n minus x power n by denominator can I write x plus h minus x? Can I write x plus h minus x? Can I write? That we can write x plus h minus x, right? Generally, I should expand this, I should simplify. Instead I'm telling like this. You write x plus h minus x. Now remember we have one formula. Limit x tends to a, x power n minus a power n by x minus a, which is equal to n into a power n minus 1. We know this formula. Correct? We know this formula, right? Suppose if I use that formula. Correct? You know that formula, right? If you use that formula, is possible? Okay. You know this formula here. When you know this formula, apply this formula here. Same thing. N into. Because h tends to 0. I want x approaches to a. You think here x plus h approaches to x only. When I have written like this, even if you want, I can write here x plus h, add x on both sides, approaches to x. Compare with this formula. Then I can apply n into a power in the place of x, x power n minus 1. So this will be our answer. So now standard d by dx of, I can write d by dx of, so d by dx of, I can write x power n always equal to n into x power n minus 1. So remember as a formula this. Derivative of x power n equal to n into x power n minus 1 always. This standard. D by dx of x power n, n into x power n minus 1. So using this you can do anything, right? I can write, this is formula you can remember. Just observe here what I have done. This is f dash of x. Then replace x is x plus h. Then simplify this. Use this formula. Then you find the derivative of x power n is n into x power n minus 1. The purpose is even whenever you want you can see this video. That's the reason I am doing like this. So you can see now d by dx. So now you can see d by dx of x power 1 you want. You derivative of x power 1, what it comes? N into x power 1, you will get 1 here. 1 into x power 1, you can see this, this will be answer 1. You know d by dx, you want d by dx of x square. Correct? You want d by dx of x square. You find d by dx of x square now. D by dx of x square. So it comes 2 into x power 2 minus 1. It will be 2x. Now like this, d by dx of x cube. Think about x cube. So same thing. 3 into x power 3 minus 1. It will be 3x square. Decreasing the power of the variable. Correct? Like this you can find. Sir, can I do like this? D by dx of 1 by x. Yes, you can do this. Derivative of 1 by x. 1 by x means how to write? D by dx of x power minus 1. Correct? I can write like this. If I apply the formula, just see the what is the previous formula of n into x power n minus 1. So I can write minus 1 into x power minus 1 minus 1. It will be minus 1 in minus x power minus 2 minus 1 by x square. Most important one. We are going to use frequently this. So we are going to use frequently this. You can remember d by dx of 1 by x always minus 1 by x square. So remember this. That is important. Most frequently we are using directly can use this concept. Derivative of 1 by x minus 1 by x square I explained here. But in the exam they may ask find the derivative of 1 by x by using first principle. Find the derivative of 1 by x. They will ask find the derivative of f of x equal, they will ask like this. The derivative of f of x equal to 1 by x by using first principle. By using, they will say, using first principle. They will say by using first principle. Then you can think how to do that. You have to try to do that by using first principle. They will ask using first principle. When they are asking using first principle means you know the answer. The purpose is derivative 1 by minus 1 by, you know the answer, you remember that. For output you should get minus 1 by x square. The output should be minus 1 by x square. What I am suggesting here, when I have written like this, f of you write again formula, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h you can write using first principle. If we are asking first principle, should not use the previous method. You should not apply that formula. d by dx of x power n into x power n minus 1, you have done that. You can see that you should not apply. When they are asking first principle, you should not do like this. This method you should not do. They are asking first principle. First principle means you should do only this method. I can understood now. Only this method you should do. If we follow this method, limit h tends to 0, f of x plus h, 1 by x plus h. How sir? F of x means 1 by x. Replace x with x plus h, 1 by x plus h. I can write this is 1 by x plus h minus f of x, 1 by x. By h is there, by h. Now limit h tends to 0. Right? I can also write limit h tends to 0. This one you take LCM, you will get x minus h by, you will get x plus h into this x into h also, it will come denominator. Here x will get cancelled. So this will become limit h tends to 0 minus h by, you will get x plus h into, you will get x into h. H also can eliminate. Then you will get limit h tends to 0. You can see now. I hope you are understanding right. Any doubt you can ask me now. Limit h tends to 0. I can write here. Limit h tends to 0. Alright. Limit h tends to 0. This will become, you will get minus 1 by x plus h into x. Apply the limit. If apply the limit, minus 1 by, you will get x plus 0 into x. So it will come minus 1 by x square. Correct? This is using first principle. You observe here, I can go back like this, I can see this. This is the required answer, right? When they are using first principle, please do like this only. You should not use d by dx of x power n using first principle. Definitely one of the questions they are asking is a CBSE or PUC. So find the derivative of the given function by using first principle. Because we can derive all the formulae by using first principle. This is the main important concept. Derivative of f dash of minus 1 by x square. You understood that after finding, sir, any function I can find this. I will explain, taking even trigonometric functions also. Sometime they will ask, find the derivative of the constant function. So next problem. Next, find the derivative of the constant function. Find the derivative of the constant function. Find the derivative of the constant function. F of x is equal to, you know constant, I get anything. F of x is equal to c. F of x or f of x equal to anything. F of x equal to c for a fixed real number c. For a fixed real number c, I have taken c as constant. Find the derivative of here. Find the derivative of the constant c, constant function. You know about what is the meaning of constant function? There is no change in output. Output will be fixed. F of 1 equal to c, f of 2 equal to c. You replace x in the place of anything. You give any input, but output will be fixed. For example, I will write f of x is equal to 6. F of anything will be 6 only. F of 1 equal to 6, f of 2 equal to 6. I told you that one. When you are talking constant function, suppose if in any function, if the output is having only one element, that means the range is having single element, then that is called constant function. F of x equal to 6, constant function. No change in output. Yes, c is a fixed real number. Then ask what is the derivative of this function where c is a fixed real number. So what they are asking, what is the derivative of that function they are asking. What is the derivative of that they are asking. Now we should work out what is the derivative of that function they are asking specifically. Now when they are asking derivative of that function, see here. Now the people, I think some people are not joined, still be in the class. uh, constantly should view this class. In between it should not go out. The thinking it is recorded, we can see that. Now f of x equals, for example, C now. When I have taken like this, now you write the formula again. F dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. You write this. This is the formula, first principle formula. Correct? You write, this is the formula you write. Now, limit h tends to 0. When I have written this, limit h tends to 0, limit h tends to 0. What is f of x plus h? Output, there is no change. F of x plus h, you can think. F of x plus h also c. There is no change. So it will come c minus, f of x is c. C minus c by h. Limit h tends to 0. 0 by h. You will get limit h tends to 0. 0 by anything 0. Limit of constant is constant. That means when the derivative of constant function is 0. Correct? What we concluded now? The derivative of constant function is always 0. The derivative of constant function is always 0. So d by dx, always remember here the conclusion. You write the conclusion. The derivative of constant function is always 0. The derivative of constant function is always 0. Now I can write d by dx of d by dx of, right? D by dx of c equal to d by dx of c equal to 0, right? The derivative of I got that. D by dx of c, I can write this is c is constant. Derivative of c equal to 0. Where c is constant, you can write where c is a constant. Where c is constant number. That means I have one doubt, sir. Can I write d by dx of 1, 0, d by dx of 10, 0, d by dx of 15, 0, any constant. Derivative of constant is 0. When they are mentioning, suppose d by dx of a, where a is constant, 0. When they are mentioning, the answer is 0. So remember, derivative of constant is 0. Derivative of constant is 0. So now, up to now what I have discussed, this always remember, d by dx of x power n, we discussed n into x power n minus 1. Remember as a formula this one. And I'll again also remember, derivative of x most people use. Derivative of x is 1 and d by dx of 1 by x we are going to use many times, minus 1 by x square. If I not remember this, use formula. You can find it. I'm going to use frequently this. Derivative of 1 by x minus 1 by x square. Derivative of constant, just now we have discussed. Derivative of constant is 0 always as a formula. Derivative of constant always 0. So this is also standard. Remember, many times you are going to use this. All derivatives of these functions. Derivative of x power n, n into x power n minus 1. Now suppose I want d by dx of root x. Derivative of root x. How to find derivative of root x? Think they are asking when the derivative of root x. When they are asking derivative of root x, I want to find. So derivative of root x means, you think x power 1 by 2, right? X power 1 by 2. So I can write d by dx of x power 1 by 2. Now can you find derivative of this using this formula? They didn't ask, find using the first principle. If they ask, we can go that method. So if the x power 1 by 2, 1 by 2, x power 1 by 2 minus 1, it comes, I can write, you can simplify 1 by 2, x power minus 1 by 2, it will be 1 by 2 root x. This is the derivative of root x, 1 by 2 root x. So conclusion you can write d by dx of root x is equal to, this always I can write d by dx of root x. So d by dx of root x is equal to 1 by 2 root x. Correct? Like this. Suppose if they are using first principle, how to do that? Think how, if they are asking using first principle, how to solve that? You can also think here how to solve that by using first principle. Using first principle, how to solve that? Again, you can go ahead. You should learn that. I told standard form also. For using first principle, find the derivative of, they will ask means, find the derivative of f of x is equal to root x by using first principle. By using first principle. Think, you try to solve it now everyone. Find the derivative of f of root x by using first principle. So when they are asking by using first principle, then same concept I can write. Again, f dash of x is equal to limit h tends to 0. I can write f of x plus h minus f of x by h. Now you can see here, I can limit h tends to 0 when I have taken this. But we know the answer. Like this you can know, you know the answer. But here I can write now limit h tends to 0. Limit h tends to 0. F of x plus h. I can write x plus h whole power 1 by 2 minus x power 1 by 2 because f of x by h. In the place of h can I write x plus h minus x, add plus x, subtract minus x. Now we know the formula. Same thing, limit h tends to 0. I suggested you, when limit h tends to 0, add both sides x. X plus h approaches to x. Then I have written x plus h whole power 1 by 2 minus x power 1 by 2 by x plus h minus x. You can apply the formula. Limit x tends to a, I told you the formula. Limit x tends to a, x power n minus a power n by x minus a, always n into a power n minus 1. If I apply the formula, n means 1 by 2 x power 1 by 2 minus 1, 1 by 2 x power minus 1 by 2. It will come 1 by 2 root x. Correct? You can see the previous one. What I have done, verify this. Correct? I got this is the answer, right? So you can see derivative of t by root x 1 by 2 root x. Same thing we got here also, 1 by 2 root x. Correct? Particularly when they are asking using first principle, you should do this method only. You should not do the previous method. That is most important point. I hope you understood that. So like this we can find derivative of this. I have taken this one. Next, before doing other functions, like about the polynomials and doing other functions here, what I will do now, here I will write like algebra of derivatives of functions. Algebra of derivatives of functions. Algebra of derivatives of functions. Derivatives of functions. Algebra of derivatives of functions. Algebra of derivatives. Algebra means, suppose they are giving two functions addition, how to find derivative of that? Difference of two functions, product of two functions, how to find that? Or quotient of two functions, how to find that? So for algebra of derivatives of functions, I can take, let f and z, you take two functions, f and z be two functions. You can let f and z be two functions to such that their derivatives are defined. Consider two functions be two functions such that their derivatives always their derivatives are defined in a common domain, are defined in a common domain. In a common, you can think of it in a common domain. What is the meaning of a common domain? Then only because to define f and z, derivatives of these functions, both should have common domain. F and z, this is z, f and z be two functions such that their derivatives are defined in a common domain. In a common domain, you can define this. So what does that mean? First one, I will write the first one. D by dx of, they are mentioning f of x, they are given f of x plus g of x. So they are given how to write this one. If they are given sum of two functions, I can express d by dx of f of x plus d by dx of g of x. I can write. Derivative I can do this. This will become f dash of x. Plus this will become g dash of x. I can add like this. Suppose they are talking difference of two functions. Same thing I can also write when they're asking. So difference will be same when you're talking here. When they're talking difference of this d by dx of. So d by d, when they're talking d by dx of. Correct. D by dx, then they're talking d by dx of, you write this d by dx of f of x minus g of x. This is x. Difference of this, I can write d by dx of f of x minus d by dx of g of x, we can write. G of I can write, this will become, I can write f dash of x minus g dash of x. Correct? Difference of two functions. And third one, when they're talking product of two functions, d by dx of f of x into g of x. Product of two functions, when they're talking product of two functions, d by dx of f of x into g of x. The product of two functions. So this is important. When they're talking product of two functions, I can write first function into derivative of second function, d by dx of g of x, plus second function into derivative of first function, I can write like this. So this will become f of x into g dash x plus g of x into f dash of x. The derivative of g of x is g dash of x. Derivative of f of x is f dash of x. This is called product rule. You can remember, this is called product rule. I can say this is product rule. I can say product rule. This rule is called product rule. The third, this one. What I will now take, this is called product rule. What I defined here, this is product rule. Product rule important. I will tell you all examples. Product rule. First into, remember like that. When the derivative of product of two functions is first into derivative of second plus second derivative of first. I will remind you. When I am doing the problems, I will remind you all this formula. This is product rule important one. This is f of x into g of x. Or this is f of x into g of x. Product rule. Remember this. Here also I can give example, also I can give that. I will give one after one examples I can give. The product rule. Because the terms what you know, for that we can do that. Just remember this is the product rule. And the fourth one. When they are talking the fourth one, they are talking about the quotient rule. So d by dx of, they are talking quotient rule. They will write f of x by g of x. F of x quotient rule. This is called quotient rule. I can say quotient rule. D by dx of by g of x. When they have taken this g of x, so they will write like this quotient rule. Denominator whole square, g of x whole square, g of x into derivative of f of x is f dash of x minus f of x into derivative of g of x, g dash of x. This is called quotient rule. You can write in the bracket, you can write quotient rule. This is called quotient rule. Some people they will say this is called u by v rule. Why they say u by v rule? They may consider f of x is equal to u and g of x is equal to v. F of x is equal to u and g of x is equal to. Suppose if we consider f of x is equal to u and g of x is equal to v, where u and v are functions in x, where u and v are functions in x, u and v are functions in x. When they have taken f of x is equal to g of x is equal to v, they will also write d by dx of u by v. So just simply, where f of x means u, g of x means v, they will write v square, v into derivative of u dash, u into derivative v dash. This way also they can write. Quotient rule to understand, same thing. This is called quotient rule. Most important one. I'm going to explain the problems, how to use quotient rule, how to use product rule, everything I'm going to explain the problems. So here we discussed about all four formulas using algebra of derivatives of functions. This algebra derivatives of functions. So this is quotient rule. Correct. And the another one I told product rule. And the next one, first and second, here both are difference of two functions. addition of two functions. In all the cases, always remember here this one, f and g be two functions such that the derivatives are defined in a common domain. We should define in a common domain. Then we can use this. The derivatives always are going to use frequently these all four types of algebra of derivatives. Algebra of derivatives, these are the algebra of derivatives of functions. Okay, now, before defining all that, because the derivations is not a product rule and quotient rule derivation is not required, just you should know this. But you should remember how to do that. That is most important. You should not forget about that. Then, now I can solve the problems like before solving the problems, even I can explain to find the derivatives of trigonometry functions also. To find derivatives of trigonometry functions, I can explain that. Now, before that, we will solve the problems in exercise 3.2. After coming to the derivatives of functions, I can explain this product rule, quotient rule I can explain. Okay, now coming to the exercise 13.2, at least I can do half of the 13.2 exercise. 13.2 exercise I can do that. After that, if I start doing the trigonometry functions, then I can explain how to find the derivatives of trigonometry functions. Now coming to that, at least few problems will solve using 13.2 exercise. Right, 13.2 exercise. Exercise 13.2. Exercise. Right. Now first one. Find the derivative of, see the first problem. Find the derivative of x square minus 2 at x equal to 10. They are asking find the derivative of, x square minus 2 at x equal to 10. They are asking at x equal to 10. They didn't ask by using first principle, right? If they ask first principle, you can use first principle. This is they are asking. Find the derivative of x square minus 2 at x equal to 10. Derivative of x square minus 2. Derivative of x square minus 2 at x equal to 10. So then, sir, after 2 minutes. Yeah. Find the derivative of x square minus 2 at x equal to 10. They are asking this function at x equal to 10. You can consider here f of x equal to x square minus 2. Correct? You take x square minus 2. Then you write the formula f dash x is equal to, you can write the formula f dash x is equal to limit h tends to 0 f of x plus h minus of, no, if I use this one, first principle, but here first principle is not, you learn the formula, right? I can directly, can I write f dash of x is equal, can I write derivative of x square, 2x constant 0, correct? F dash x equal to 2x I can write. Now f dash of 10 I want. So you think f dash of 10, replace x with 10, correct? You replace x with it. We know here, so how you have written this? We learned x power n formula, d by dx of x power n formula, n into x power n minus 1. And the d by dx of constant, we know constant is 0. Use this formula here. This will be 2 into x power 2 minus 1, constant is 0. Correct? I will get like this. You understood what I have written here. Now f dash of x is equal to, it will come only 2x. They are asking at x equal to 10. So f dash of 10 equal to, it will be 2 into 10, answer will be 20. Am I right? It gives 20. Second one. Find the derivative of x at x equal to 1. Is it clear? Anyone have doubt? Please update me. Is it clear? I have doubt here. Is it clear? The problem is clear. If you have doubt, please ask me. I can explain again. Understood that? Is clear? Right. Is clear that? What I explain? Is clear? All right. Fine then. So what I will do now, I will within 2-3 minutes I will complete that problem. Find the derivative of, yes, if I am going this one, I can write, find the derivative of the next problem. Find the derivative of x at x equal to 1. Find the derivative of, we are asking, find the derivative of x at x equal to 1. Find the derivative of x at x equal to, find the derivative of x at x equal to 1. When they are asking derivative of x at x equal to 1, can you think like this? The given f of x is equal to x. Now can you write f dash of x is equal to, derivative of x is equal to 1. Use the formula like that, n into x power n minus 1. If you write 1 into x power 1 minus, it will be 1. F dash of anything, f dash of 1 will be 1 only. I have doubts, sorry, the derivative of x at x equal to 10 also same thing, 1 only, there is no change. Find the derivative of x at x equal to 1, same thing. Find the derivative of x at x equal to 100, no change. Answer will be 1 only. Correct? You think I am asking derivative of anything. Find the derivative of x at any number, there is no change. Answer will be same, 1 only. Right. Third problem. The third one I am saying, find the derivative of 99x. Find the derivative of 99x at x equal to 100. They are asking find the derivative of f of x is equal to derivative of 90. They are saying derivative of 99x. Derivative of 99x at x equal to 1. Now take f of x is equal to 99x. Right? You take f of x equal to 99x. Take f of x equal to 99x. Then you find f dash of x, that will be 90. Derivative of x just we have done. Derivative of x is 1. It will be 99. They are asking now f dash of 1 at 1. This will be 99, no change. 99, derivative of x is 1, 99. F dash of 1 will be 99 because the right side is constant, right? The value we got constant, 99. There is no change. Correct? Is clear? Understood this? I hope you understood this, right? Because this is clear. Same problem, I can do one more problem. We can solve with that, right? I hope the answers are clear, right? So one more we can do this. Find the derivative of the following with the first principle. What they are asking, using first principle they are asking derivatives. Find the derivatives of the following with the first principle. They are given, for example, I will explain with 4 problems are there. I will explain this one. With the time, as for the time, I can consider like I will do 1 by x square. Other problems I will do in the next class. At least within the 3 minutes you can complete. They are asking find the derivative of following functions. I will take f of x equal to 1 by x square. They are asking what is the derivative by using first principle. F of 1 by x square from first principle. They are asking from first principle. Only first principle they are asking. So when they are asking first principle, you should use only first principle. With this we will stop here. Next further questions we will discuss next class. So first principle when they are asking, first you write formula. Definitely they will give 1 mark. F dash x limit h tends to 0. F of x plus h minus f of x by h. Minus this I can write our convenient. Limit h tends to 0. 1 by h you can write outside. What is f of x plus h? 1 by x plus h whole square. Correct? Observe here. This is f of x means 1 by x square. F of x plus h. Replace x with x plus h. 1 by x plus h whole square minus 1 by x square. It comes like this. Correct. Now you can see this I can write limit h tends to 0. Limit h tends to 0. 1 by h. You take LCM. It comes x square minus x plus h whole square by I can write x plus h whole square into x square I can write. Correct. Now in the numerator you can apply a plus b a minus b can apply. Correct. You have taken like this. I can write limit h tends to 0. I can write because limit h tends to 0. Limit h tends to 0 1 by h. This one can you write a square minus b square. So you can write a plus b, x plus h, correct, into x minus h by, I understood this one, correct, I can write like this. Because how I written this one, you understood this one, a square minus b square. I can write x plus h into x minus h by x plus h whole square into x square. Now you can see x will get cancelled here. Now you can simplify. Limit h tends to 0. I can write here limit h tends to 0. This is 1 by h. This will be 2x plus h. 2x plus h, correct? This will be minus h by x plus h whole square into x square. Problem is important only. They're asking CBSE, so they're asking this one, x square. Now you can see here, can I eliminate hh? Eliminate hh. Now substitute the limit. In the place of h0 you write 2x plus 0, minus is there. Minus of 2x plus 0 by, in the place of h0 you can write x plus 0 into x square. Correct? I have written mistake here. This is x plus h whole square. Here also x plus h whole square. Here whole square. So it will come now minus 2x by x square x power 4. It will come minus 2 by x cube. Like this. Sir, it's lengthy to do by principle. Yes, that is true. But this way you should do that. By using first principle, there is no other option. You should do like this only. By using first principle. Correct. You just verify this. I have taken the formula of this. Apply f of x plus h minus f of x by h. Then you substitute the values. Simplify. Then finally you substitute the limit. So we got this one. That means derivative of, finally I can conclude, d by d I can write d by dx of, so after writing this one, d by dx of, I have taken 1 by x square. So 1 by x square always equal to 1 by x square equal to minus 2 by x cube. This is the conclusion, right? Then but, so before doing this, can I verify this? Whether I have done correct or not, you can verify. So what can you do this? Before you can verify also. Beginning itself, suppose d by dx of 1 by x square. Can I write d by dx of x power minus 2? You know formula, x power n formula. Minus 2 to x power minus 2 minus 1. So that will be, always you see, it gives same answer, right? It will be minus 2 by x cube. Correct? Understood this? We can write like this. We can verify beginning only. By that, before doing first principle, you can verify your answer. You can right side, you can do this rough work. Yes, perfectly. After doing, you can decide this is my answer like this. Using x power n formula I have done here. Using x power n formula. You can verify this is your answer. Like this you can conclude this. So this is your answer here. Like this, I think, I hope I can, today I can end this session. I can conclude this. I hope everyone understood this right. Then see you in the next class then. Hope it's clear. Then I will come back to the classroom just 1 minute. Okay, then fine.